AP Calculus video part 7, number 9, it's continuity, sorry, this is chapter 2, continuity of AP Calculus. Number 9, at what point is the removable discontinuity for this function f of x? When we have removable discontinuity if we have rational function, right? Rational expression with common factors in the numerator and denominator, because these factors, when we factorize the numerator and denominator, we cancel them. The discontinuity is removable. We remove the discontinuity. In practical terms, this means that the discontinuity occurs where there is a hole in the graph. When we draw, and this hole represents this discontinuity that I removed. This, not continuity, discontinuity that I removed. Let's try to factorize this. If we factorized f of x, right? It's x minus times plus, and the 24 is 3 minus 3 times plus 8, because plus 8x minus 3x gives me 5x. That's correct. And here, what do we have? We have x times x minus 3 times plus 2, because negative 3x positive 2x gives me negative x. We remove x minus 3. The answer of f of x will be x plus 8. What left is x plus 8 over x plus 2 after cancelling the x minus 3. Now we can substitute f of 3. Plugging this 3 in this function, it gives me 11 over 5. So the point 311 over 5 represents the removable discontinuity. At this point, if we draw, we have that hole. Number 10. Number 10, given the function of f of x above, it's not clear, I know, I will help you to see what we do have here. Given the graph f of x above, find what is the limit of f of x where x approaches negative infinity. Look at the graph now. As x approaches negative infinity, as it goes more and more and more and more to negative infinity, we can see that the curve, the graph, is going, as we go further to negative infinity, the curve will go more and more and more closer to x-axis, but it does not cut this x-axis. So x-axis for this part of the curve acts like asymptote. So the distance approaches 0. So what is the answer? It's 0. Limit of the function at this negative infinity, it will be 0. What is the limit of f of x as x approaches plus infinity? Let's see. As x approaches plus infinity, right? This curve goes more and more and more closer to the x-axis. Also, it goes all the way until the distance, not 0, approaches 0. We don't have that. This straight line cuts the curve. Okay? Limit of f of x as x approaches 3 minus. It's a 3 minus, yes. 3 minus. Here the 3, right? What is 3 minus? What is 3 minus? 3 minus is a bit less than 3. So as x approaches 3 from below, we have this point here. What is the ordinate of this point? It's 1. So the answer is 1. As x approaches, limit of f of x as x approaches 3 plus now. As x approaches 3 plus, so it goes from up to down, right? It goes from up to approach 3 plus. Also, same. It's 1. We have continuity at 1, at 3 here. F of 3, this one, f of 3. Let's see. Does f of 3 exist? As I can see, first, oh sorry, this is, I did a mistake here first. The answer of f of x of part D, it's also 1, right? Yeah, right? That's what we said. F of 3 is f of x Limit of f of x as x approaches 3 is 1. Limit of f of x as x approaches 3 plus is also 1. So the limit of f of x as x approaches 3 minus equal limit of f of x as x approaches 3 plus, right? So the limit of f of x as x approaches 3 will be exist. It should be equal to f of 3, right? Here depends. Here we depends. I don't know if this point was a hole in it or not. If we have a hole, and I think so, it's like circle, small circle. This means f of 3 exactly does not exist. We don't have it. If not, it will be equal to 1 also. So f of 3 does not exist. Let us consider does not exist, right? Let us consider, yes, we have. He's asking if there's find any discontinuities. Any discontinuities. Do we have discontinuities? Look at the figure. First, at x equal minus 3, at x equal minus 3, minus 1, minus 2, minus 3, we have hole here. Yep, we have discontinuity. Here we have point. This discontinuity is a jump discontinuity. One, we have a jump discontinuity. Another discontinuity we have at x equal 3. If yes, at x equal 3, we have a hole here. So yes, we have discontinuity. This means it is, what do we call it? Part 2. Removable, right? Removable. We removed, it's as in number 9. Removable discontinuity. We removed this point. Removable discontinuity, right? Do we have another discontinuity here? Look at x equal 5. What do we have? At x equal 5, we have asymptote, right? Vertical tangent as those continues, right, to infinity. This line will be a vertical line. We call it, if you remember, you can go back to one of the videos to see kinds of continuities, and we call this an essential discontinuity. And that's it for AP chapter 2. It's done. Continuity. See you in the next chapter.